Hello and welcome to this Tungsten Cluster Masterclass training session where we take a look at Distributed Datasource Groups or DDG. My name is Chris Parker, VP of Customer Success here at Continuant. In this session, first of all, we'll understand what DDG actually is. We'll look at any additional considerations for deploying this topology, study the configuration, and then I will show you an installation and show you it in practice. So what is a DDG topology? Distributed Datasource Groups, or DDG for short, was introduced in Tungsten Clustering version 7.1. From an installation viewpoint, this looks and acts just like a single standalone cluster with the same rules of an odd number of nodes being required to maintain quorum. What this configuration does is to allow you to partition a single cluster into subgroups based on node location or data center, while still preserving a unified view of the cluster. Each node is assigned a DDG ID, and nodes sharing the same ID act as if they belong to a local cluster for failover purposes, but could actually reside in different regions. For the active-passive topology, there is a clear distinction between two clusters that can reside in different locations. Using DDG, you can still achieve the geo-distribution, but present all of the nodes as though it were a single cluster. Under normal operation, there is still a single write primary across all nodes, but failover preferences are constrained first to nodes within the same DDG group. What this means in practice is that you can co-locate nodes in the same region or data center with the same DDG ID, so that if a primary node fails, the system first tries to promote a replica in the same site. Only when no candidates remain in that group will failover escalate to nodes in another DDG group. This gives a balance. Local failovers are preferred to maintain latency and cross-region switchovers, while still retaining resiliency across data centers in more extreme failures. So what are the configuration considerations? Well, as I mentioned, as with a standalone cluster, you need to have an odd number of nodes, and all of the usual prerequisites that we covered in our earlier sessions need to be in place. For network connectivity, not only do you need to ensure local cluster nodes can communicate, but you also need to ensure they can communicate across regions, if your separation is across region. This could have additional security considerations within your organization and should be handled accordingly. A full list of the network ports required and all of the prerequisites are listed in our documentation. You need to ensure that network latency between nodes is adequate to ensure timely replication. While we do not have a documented minimum latency expectation, you should be aware of the implications of high latency. Finally, the connector behavior. All connectors will always route right to the primary node, with reads balanced across all of the replicas depending upon your choice of connector configuration. I do not cover those specifics in this course, however there is extensive documentation at docs.continuant.com that will guide you along with our support services and also our connector-based training sessions. So let's have a look at a sample configuration. The configuration is very straightforward. It has the default section and the cluster section. In this example here is showing as alpha, with one node being identified as the primary, in this case DB1. The only difference here is that you include the datasource-group-id parameter in the default section. This value needs to be set differently on each node, but with all nodes within the same group getting the same ID. So for example, you could group DB1 and DB2 into a group and give the configuration on those hosts datasource-group-id of 100. For DB3 and DB4, you can set datasource-group-id to 101, and on DB5, set the datasource-group-id to 102. What that will then result in is a 5-node cluster with DB1 and DB2 in one data source group, DB3 and 4 in another data source group, and DB5 in another data source group. And those 3 individual groups could then be distributed across regions, across your data center, or however you choose. So let's take a look at a demonstration on what does this look like in practice. So on my screen here, I have database nodes 3, 4, 5 on this tab. And on here I have database nodes 1 and 2. So let's just look at the configuration. I'm setting this up as per the example I just showed on the slide deck. So nodes DB1 and DB2 are in their own data source group. So if I look at the tungsten.ini file on here, we see I have set the data source group to 100 on DB1 and DB2. And then if I look at DB3, 4 and 5, we have DB3 and DB4 in group 101 and DB5 in group 102. So I've created these 3 distinct data source groups. So let's go ahead and actually install the software. Let's run the install on those 3 nodes. And then let's run the install here as well. And let's just wait a moment or two whilst the installation completes. Okay, we see that it's completed on DB1 and DB2, and it's completed on 3, 4, and 5. So first of all, I will just reload my environment on each of these nodes, and then we will start the software. So start all. And for simplicity, I've installed my connectors on the database hosts as well, but typically in a production environment, you would have those on dedicated hosts. I'm just keeping it simple for demonstration purposes. Let's start all over here as well. Starting the replicator first, starting the managers, and then finally we'll start the connectors or the proxy layers. And there we go. Okay. So with all of these started, let's just choose one node and let's go into ccTRL or cluster control. And from here, we see our cluster alpha with all 5 nodes listed. But what we see additionally in the output here is this line here, datasource-group-id. So we can see which nodes we have these grouped into. So all of those with the same node. And that's it. That's very simple. The cluster now operates as though it were a single unified cluster. Your connectors will take your writes through to your primary node and your reads will balance across. So what happens in terms of failures and switches and all of that kind of thing? Well, what I will do first of all is I will just do a switch. Now typically in a standalone cluster, the switch will choose any node that's available. When you are using DDG, it will only choose a node that is available within the same data source group as the current primary. So the primary is DB1, therefore issue a switch and it's only ever going to go to DB2. When I'm at DB2, if I switch, it will go back to DB1. It will only go between those 2 nodes, unless I specifically say I actually want to switch to a different node. So we're at DB2 now, and we see we've promoted DB2 as the primary, DB1 is now a replica. If I just do the switch back, you'll see it'll go back to DB1. It's within the same data source group, so it has to maintain that consistency, and it will switch back to there. And this will be the same in the case of a failure. So if we lost the primary node, if we lost DB1, we would promote DB2. If we lost DB2 and we've already lost DB1, only then will it promote a node within another data source group. So let me just show you this. We have DB1 is the primary. So what I'm going to do now is I'm going to just do, I'm just going to brute kill my SQL. So that will force a failover. So we can see that primary has failed. We'll just let that carry on doing its failure. There we go, shunned, failed over to DB2. It's just taking a moment then, obviously it was just doing its checks between the nodes. So we now have a shun node, we see it's failed over to DB2. The replicator, everything is degraded, and DB2 is now the primary and is online. Eventually this will be back in automatic mode and the failover is complete. Yeah, so there we go, we now have a failure. If we were to recover DB1, great, and if then DB2 was to fail, it would go back to DB1. But let's see what happens now when we lose DB2. And we should see it will then promote one of the other nodes. So I just need to come out of ccTRL. I will just take that same stop command on here and force stop the database. And then I'm just going to jump over to one of these nodes and let's just open up ccTRL over here. And let's see what's happened. So we can see that it's detected DB2 has failed. I'm just going to make this screen a little bit larger. And we'll just wait a moment or two for the cluster to go through its process. And we say the master has been shunned and it's elected DB5. So it's taken DB5 in data source group 102. So that has now been promoted. So that's how it's effectively a failover across a region effectively. So unlike active passive, where if you lost an entire region you would have to manually fail over to another region, this gives you the benefits of that without actually having to do those manual failovers. It also means that you could potentially have a smaller cluster that is still distributed. So if you're using active passive, you would have a requirement of at least 3 nodes per cluster. So if you wanted to do an active-passive configuration across 2 regions, you would need 6 nodes. If you were to use DDG, you could still do that with 3 nodes, where you could have 2 nodes in one region and a single node in another region. So you could have a much smaller footprint of nodes if your application doesn't need that size of deployment. And that's DDG. So let me just switch back to our slide deck. So in summary, what have we covered? Well, we've reviewed what DDG is, so Distributed Datasource Groups. Okay, and we have a documentation page that covers this as well. It just goes through what I've shown here. It's very simple and very straightforward, so do go check that out if you're interested. We've looked at the configuration and the architecture, and I've shown you a demonstration of it in action and how it works. So I hope you found that useful. It was quite a short session. It's very straightforward, but actually a very powerful topology that can be very useful in different use cases. So thank you for listening, and I hope to speak to you again soon on another training session. Thank you and goodbye.